Good morning. I know I'm the only thing standing between you and lunch, so we'll make this as quick and painless as possible. There's been a lot of talk recently about that AI is really the threat to the human race. Yeah? But in reality, AI is just computer science. And so there's a number of areas in artificial intelligence, in AI, that are very well established. One of them is machine learning, and the other is natural language processing. And of course, there's quite a few other areas as well. But machine learning is something that is actually really matured. And it actually makes a large part of many of the processes that we do at Amazon. So what I want to do with you today is actually give you a bit of a tutorial of what actually is machine learning, how does it work, and then look at some of the application areas and some of the services around there. So data, of course, it's all about data. It's all about driving, using data to become smarter. So there's, of course, many different areas in the applications that we build. They're all data-driven. But if you look at sort of the more analytic side of things, then one particular area of analytics is all about retrospective, really looking back, basically generating reports. And whether that is sort of traditional business intelligence, where on forehand you already know what kind of questions you want to ask, that drives the data model, and that drives sort of the data that you collect. Or whether that is sort of a big data approach, where it's much more iterative, where you have collected as much data as that you can, and then iteratively you go through the data to look whether there's a pot of gold in there. But all of that is sort of looking backwards, looking at the past. Second area of much data-driven development, which is something that is really heating up, is doing things in real time. Yeah, where you have massive data streams coming in, whether that is from your applications or from, let's say, IoT devices or instrumentation of large industrial machinery, all the data flowing into sort of the cloud, being analyzed, and then vended back in with real-time dashboards. So really, real-time data analytics is definitely an area that's really heating up, and this is actually also pretty established already. But there's a third area of data-driven that is all about, not about the past, it's not about now, it's about the future. Can you make use of data that you have to make predictions about the future? And so there's lots of technologies for that, but the main technology that you use for this is called machine learning. Yeah, and so it is a way to actually make use of data that you already have to build models such that you can make an educated guess about the future. And so doing that, having that data and combining that with machine learning allows you to build much smarter applications. So if you look at some of these examples, for example, you know, how do you know whether your customer is going to use your product or is interested in your product? Yeah? If you get an order in, what is the likelihood that this is a fraudulent order? Or, you know, based on sort of other things that you know about your customer, or if you've read this particular article, what other articles would you recommend? All of those things are stuff that you see in your daily life already. It's all driven by machine learning. And if you look at Amazon.com, we've been using machine learning forever, almost from the beginning. And these are just a few of these areas. Yeah, so for example, in the retail side of things, how big should your inventory be for a particular product? What do you estimate about lead time for your vendors? Yeah? What kind of packaging should you be using for this particular order? Or whether it's fraud detection, or whether it's recommendations, yeah? Or automatic classifications of products. All of these things are driven by machine learning. Yeah, and so, for example, the whole personalization world, where we basically create a unique website for each of our customers, is all driven by machine learning. And so if we step back a little bit, I want to talk a little bit about personalization, because it's such a familiar area for each and every one of you, not only if you use Amazon, but probably every retailer or every e-commerce operation today makes use of personalization and recommendations to create a better experience for you. So this personalization consists of 3 different areas. Yeah? One is similarities, one is recommendations, the other is zeitgeist. So similarities is all about item to item. Yeah? Customers who bought item X also bought item Y. Or who viewed this also did that. Yeah? Or these two items are frequently bought together. Recommendations is all about item to customer relationship. Yeah? Based on your history, based on other things that you've bought, what would be interested for you to do. Not only the current category, but if you like this movie, maybe you also like this music. Yeah? And so there's all these relationships that you can build. Zeitgeist is all about sort of bestsellers. Yeah? Basically, what are other things that are going on the site? Yeah? Or what are other people that in the same category like you, whether it's students or whether it's mothers or young mothers, or what are they doing? And in real time, not, let's say, a bestseller list like the New York Times publishes once a week, but a bestseller list for each individual category that you have. And so those things are really important for customers to make their decisions. Personalization is not only to actually narrow things down to help you buy a product. There's another area that is really important. I don't know if you've ever heard of this. It's sort of a sidestep. The paradox of choice is all about the more choices you have, the less likely it is going to be that you're going to be happy with your choice. So if you go to a grocery store and there's only 5 toothpastes available for you, it's not that hard to choose which ones you want. And actually walking away with the idea that you've made the right choice. If there's 50 toothpastes there, you may even still buy the same toothpaste, but there's this nagging thing in your mind that you may have made a mistake, that you might have made a much better choice. And so the more choices you have, the less likely you are to make a choice. And even worse, the more likely it is that if you do choose something, that you're going to be unhappy with that choice. And so in the retail stores, maybe you have 20 different toothpastes there. In the online world, this is even much worse, because there will be 5,000 toothpastes for you. So the number of choices are much bigger. So personalization is the technique we use to make use of machine learning technologies to help you reduce the choice. So it's that the likelihood that you're going to be happy with the choice that you make is much higher. Now let's go do something way more traditional. Yeah? Imagine you've all had these sort of emails, sort of marketing emails that you get in your mailbox. Yeah? And in the old world, what you had to do is probably people would write SQL queries like that. Yeah? So you write a query that says, well, we're going to send this offer to all customers who've placed an order in the last 30 days. Well, that seems, if you have that many customers like we have, you know, that's a very large number. So let's reduce it. Oh, people that bought toys. Yeah? Or people that actually bought helicopters. Toy helicopters, not real ones, of course. But, then, oh, but we also should actually send this offer to people that bought quadcopters. Yeah? And then maybe we should go back further in time, or maybe we should actually get better people that bought multiple toys, we should send this offer. So all these kind of things are ridiculous, because it actually is so fixed. It doesn't learn from anything. Yeah? The way to do this is to make sure that you use machine learning to take data from the past to build a model to predict the future. Which of these customers are likely to enjoy this offer if they get it? So imagine you have a data set like this. Yeah? Here you've got customers, and this is a data set from the past, and it's all about that particular column there. Yeah? You send them an email. How many of which of these individuals have actually clicked on that email? And what you then do, you use this data from the past as your training data. What you then do is you develop algorithms around it, and you create a model based on that, which you can use as sort of a predictive engine for, if you give it then other customers, what you think is the likelihood that they are actually going to click on that email. And so you will then have another data set that is potential customers that you want to send this email to. And so what you do is then feed that data into the model, and out will come predictions whether or not which of those customers are very likely to click on that email. Yeah, and you get something, an output that says basically, these customers are very likely to click on it. Now, in reality, it's not a yes or no. Yeah, you have some sort of prediction score, statistical prediction score based on the original data. And depending on where you actually set sort of the taper-off point, yeah, if you put it at 0.8, then you get a different set of customers than if you would put it at 0.5. Yeah, and so all of this is very open to interpretation. And so let's look at some of common patterns. Yeah, as I said earlier, it's a fraudulent order detector, which is a binary classifier. Yeah, an idea, is this going to be, is this a fraudulent order or not? Yeah, trying to predict based on names whether this is a female or a male customer. And the demand forecasting is not necessarily, it's not binary, that's all about numbers. Yeah, we use regression techniques there. Or if you get a book in and you want to classify it in which particular category it belongs. So that is sort of a multi-class classifier. Yeah, basically you have a set of classes where this book can belong to, and you have to pick one of those. Or an abusive review detector. Yeah, really doing natural language processing on the review to see which ones are abusive. Often you use multiple models in correlation with each other. For example, you may use a gender prediction model and then combine that with order data to get an email targeting model to get predictions out. So how we have to actually test whether the things that you do are useful. And so what you do is you actually take that data set that you have and you take 75% of it to use it as your training data, and you take 25% of the data as your input data. So because you already know what's going to happen there, and you're going to test the model, how good it is. So 25% of the original data goes into your model, and then you see whether the outcomes are actually truly the predictions that you would have made. And so accuracy plays a really important role in this. And you're going to tweak your algorithms in a way to get ultimate accuracy out of it. And so you do this for each of the quarters of your data set. So basically, you continue to train your model and use data that you already know from the past to see whether you would have accurately predicted the past. And so, is it good enough? If it's not good enough, then you go back to either you improve your data set, or you're going to tune the model to get the accuracy that you're looking for. And then in the end, after a number of iterations, you'll get a final model that you then can integrate into the other part of your business that you do. Often, binary classifiers are the easiest ones to make. And so you may actually first use a binary classifier, which is yes or no. And if you follow then the yes path, you may have a regression model that actually gives an exact number that you're looking for. And so why isn't this that the whole world is full of machine learning applications? Yeah, it is actually, it turns out, it's very hard to do. If you have, you really need data scientists to actually do this for you. There's so many different algorithms out there that you can use to actually using your model. And then it's very hard to go from a model to actually having software that does this for you. And so within Amazon, we saw this. We saw that many of our engineers are spending enormous amounts of time building all these models. Even in all of those places where we were using it, they were doing this the hard way. And so we decided to build a service, a machine learning service internally. And so we did this experiment. This is sort of the binary classification. In this case, I think what we wanted is, if you take an individual's name, can you predict whether they're male or female? And so two very experienced developers took 45 days to build something with 92% accuracy. And we've built this service that does actually most of these things behind the covers for you. And a junior developer was able to get the same thing done using this service in 20 minutes. And so while we delivered this service, it sparked a whole range of new style of development within Amazon. Lots of different applications were being made. And so what we decided to do is that, given that there is such a huge opportunity for everybody to integrate machine learning into the applications that they're building, we decided to launch it as a public service for everybody to use. So there's something called the Amazon Machine Learning Service that you can use to build your machine learning applications. It's just like all the other services that we built in our cloud computing division. It's a managed service. You don't have to run any servers for it, or you don't have to run software. It all is being run for you. You can drive as much data into it as you want, and it easily integrates into other applications that you want to build. And so it's built really on top of the Amazon algorithms that we use internally and are now available for you to use as well. And you can easily train it with hundreds of gigabytes of data. So scaling this is pretty easy. End-to-end service. And there's a very cool thing in that you can actually integrate it into anything that you do, every application that you build. But let me show you how this works. So first, of course, you start off with building a model. So as you can see here, you can't see it here because that's PowerPoint just crashing. Serious. So let me finish this one. Although I do need the PowerPoint set back up, please. Let me see. My clicker doesn't work, it crashes again. Yeah, okay, so can you push it 2 slides beyond that? Or the next slide after that. So you build a model. Basically what you do, you pick a data set that you have. You decide whether this is a numeric data set or whether it's an image data set. And you then decide how wide the bins are that you're going to want to make use. Okay, leave it here. After that, you get a graphical interface like this. And I'm sorry I can't show you here in real life, but what you can do is you can move, for example, the threshold back and forth and see how your accuracy and how your false positive and false negatives change over time. And then what you can do is actually use this, push a button, and say, deploy this as software. So you've created this model purely visually, and then with one click of a button, you can say, turn this into a service that I can call from any of my applications. And so, for example, an application could be some mobile app where you place an order, you store it in a database that triggers some functionality that will then go to the machine learning service and take this order and ask the machine learning service what the likelihood is that this is a fraudulent order. So this means that any of you can now integrate machine learning into each and every one of the applications that you have. And it's not just boring numbers. There's lots of things around machine learning that have to do with imaging or video. These days, video and imaging and audio are no longer things to be watched or things to be listened to. They are actually data streams that can be analyzed and integrated into the things that you do. You can have, this will be a binary classification. Is this urban or not? Is this a healthy CT scan or not? More is, of course, when you get to multiple choices, like which city is this one? We all know that this is, of course, Hong Kong, but or what kind of tumor is this one? All of these kind of things can be done with machine learning. Also, find the object in this picture. What is the set of pixels that holds this object? Of course, this is an easy one. It can be a lot harder if all of them look exactly the same. Do you know actually why zebras have these stripes? That if you put them together, lions have a very bad eyesight. If you put all these zebras together, it looks like one giant zebra to the lions. That's serious. That's why these guys have stripes. So where's the object is harder in this case? And so machine learning is used to actually segment data on the screen into different areas. Which is the car, or segment these into the different muscle groups. All of these things are done by machine learning and can be done by a simple machine learning service like that we just delivered to you. And another area where machine learning plays an enormous important role is that in robotics. And whether it is drones that need to fly autonomously, or whether it's these robots in our warehouses that need to find the products and then take them to the people that have to ship them for you, and without running into each other, is also all machine learning. We run a challenge every year where universities can come with their new machine learning algorithms and use robots to automatically pick things from shelves. Yeah, they need to be able to distinguish these different set of products. That's a shelf they need to be on, and then this robot needs to automatically pick things off the shelf depending what kind of products you want to run. And we run a challenge every year for either startups or universities to actually compete on building the best machine learning algorithms for this. I like to believe that with the rise of this machine learning service, there's never been a better time to build these smart applications that have machine learning integrated into them. You no longer need to be a data scientist. You no longer need to be a machine learning expert. You can use machine learning to predict the future in each of your applications right now. So with that, go build, use this service, go build smart applications. Thank you.